Okay, so for 4.4 notes, we're going to be discussing rotations in more detail. Our goal today is to identify rotations in a plane and to determine whether a figure has rotational symmetry. So, we spoke about rotations when we discussed an overview of Unit 4 in 4.1. So, rotation is a transformation where a figure is turned about. Rotation is a transformation where a figure is turned about a point. A center of rotation is the fixed point in a rotation. So the fixed point in a rotation, in this example here, you can see that the fixed point, the point that the image is rotating around, is this point O. Okay, so A goes here and it moves to A prime. B goes here, it moves to B prime. C goes here, it moves to C prime. And so then the angle of rotation is going to be how far it is turned. And in order to find this angle of rotation, if you go from the fixed point to A, and then from the fixed point to A prime, this angle right here, we'll call it theta, so a cursive O, that angle is going to be the angle of rotation. So as we did in the diagram, this is going to be the angle formed when rays are drawn from the center of rotation, so from the center of rotation, to a pre-image point, and from the center of rotation to its image point. So this is the pre-image A. Here we have the image A prime. So the angle that's formed there by those two rays, I should draw them as rays, that angle that's formed is going to be the angle of rotation. Rotational symmetry is going to be something that a figure has. So a figure has rotational symmetry if the figure can be mapped onto itself by a rotation less than or equal to 180 degrees. You'll see why that part is important in just a minute. Another thing that we talked about back in 4.1 is that a rotation is an isometry. Again, that isometry means that the transformation does not change the overall shape and size. So because of that, a rotation doesn't change shape and size. It is an isometry. Okay, so talking about the rotational symmetry first. Rotational symmetry. What I'm going to use is I literally went upstairs in my kitchen and got some parchment paper, so it's see-through. Parchment paper, wax paper, tracing paper, anything like that. And just so I can show you this, it's called patty paper in class usually, but I didn't have it. So the parchment paper works just fine. Any paper that you can kind of see through in order to trace works just fine. So an isosceles triangle, what I'm going to do is I'm going to trace this. And then what I'm going to do is the rotation of symmetry is going to be in the center of the image. And I'm going to see if I can turn this and if it maps onto itself. And you can see, I can still see that shape and it doesn't line up until I get all the way around. Okay, so you could even mark like that's the B for bottom. Okay, if when I mapped it, B is up here, that's a 180 degree turn, but nowhere in between there was I able to map it on itself. So this actually does not have rotational symmetry. It would have to go all the way back around, which is not considered rotational symmetry because it would take 360 degrees, and that's the original image. That would mean everything has rotational symmetry, which it wouldn't be anything special if everything had it. So this one, since you can't go 180 degrees or less with it mapping on itself, the answer here is no. Okay, we can try it with a rhombus. Now a rhombus is just a figure that has 4 congruent sides. And better yet, so you can see this one, I'm going to put a point on there. We'll call it B. And then when I do this, I can mark point B. Okay. Now watch what happens in this one. I'm rotating it, and it doesn't map onto itself until right here. Okay, see how it maps onto itself? It overlaps. So B was down here, it mapped up here. That's 180-degree rotation. Okay, that would be all the way back around, so that one doesn't count. So yes, it has rotational symmetry at 180 degrees. Okay, now this last one, let's try this one. Let's put a point down here. So it's now traced. This point down here is B, and since it has to be less than 180 degrees, once B gets up here, I can no longer count it. So when I'm turning this, this maps on itself there. So there's one. And here's a second one. Now I'm not going to keep counting because that's going to be my 180 degree. So I had yes, I had one at 90 degrees, and one at 180 degrees. I knew this was 90 because it was halfway in between 0 and 180. Okay. So those would be our two rotational symmetries. All right, let's flip this over. Now, these ones are going to be rules. So I am actually going to pause my screen. But what I'm going to do is I'm going to draw in A, B, and C on all of these graphs. So there are 5 graphs. I'm going to graph A, B, and C on every single one of them. And then we'll do the rotations together. So go ahead and hit pause and start plotting A at 1, 2, B at 4, 3, C at 5, 0. And if you want, I'll do the first one on video, and then I'll hit pause so that way you guys can do the rest. And all you're doing is copying them on every single one. So A is at 1, 2, so I'm going to mark that A. B is at 4, 3. Mark that B. C is at 5, 0. I'll mark that C. I'm going to use my straight edge to make this triangle. And I'm going to repeat this on all 5 of these graphs. Okay, so what I've done is I've gone through and I've drawn the triangle ABC on every single one of these. And then we're going to talk about each one individually. So this first one is rotating 90 degrees clockwise. Now clockwise is just how the clock moves. So up here, you're going to need to make sure you know the difference between clockwise, because the clock goes in this direction, versus counterclockwise, goes in this direction. Okay? So they go in opposite directions. Same way a clock goes. So think about the 12s up here. 1, 2, 3, goes in that number, the verse is going the opposite way. Okay, so rotating 90 degrees clockwise. What I've done is, again, my nifty patty paper here. If you rotate 90 degrees clockwise, Y becomes over here, this comes down here. So 90 degrees is a 1/4 turn. So what I can do, I know this focus is kind of off. What I'm going to do, though, is if I can make this turn a 1/4 turn, I can actually see where these points move to. Okay. There we go. Okay, so let's see. A moves to 2, -1, so I'm going to write these in. 2, -1. And B moves to 3, -4. And C prime is going to be at 0, -5. Okay, so let's talk a little bit about how this rule works. We know that this rule, x, y, is going to go to something. Now, what does it go to? Now, I've marked on here, here's our x. Where does the x move? X here is going to move to where negative y was. Okay. Y is going to move to where x is. So what becomes here is going to be our new x. What comes up here will be our new y. So let's actually take a look. If this is positive x, this down here would be negative x. If this is positive y, down here will be negative y. So let's actually look. We want to know what becomes x and what becomes y. Okay? So in the x spot, when I rotate this a quarter turn, what is in this spot now? It's the y. So our rule is y, comma, what is in the y spot though? So when I move this, I'm going to look at what comes up here. So I'm going to make it a quarter turn. What comes up here is a negative x value. So negative x will be in that spot right there. So let's check and see if that rule worked. Instead of in your x spot, you're now going to put the y's. So we have 2 becomes the x, 3 becomes the x, 0 becomes the x. That worked. The x value becomes opposite, and that's what's in place of the y. So the x value is 1, so we make y negative 1. The x value is 4, we make y negative 4. The x value is 5, we make it negative 5. So this will be our rule right here. Now that was for 90 degrees clockwise. Let's try to identify the rule for 90 degrees counterclockwise before we even locate this. And then maybe we'll try to find this and do it the opposite way. So counterclockwise is just going to move in the opposite direction. So again, we need to know what is in x and what's in the y spot. So when we go counterclockwise, we're going to do a quarter turn this direction. And our x is now going to be negative y. So we have negative y, comma, up here in the y spot, that's where the x was. So we have negative y, comma, x. Notice it's different than this one we had here. But let's try to come up with these points using that rule. So we're going to take the y's and we're going to make it opposite for our x value. So y was 2, so we're going to have the opposite of 2. Y was 3, we'll have the opposite of 3. Y was 0, we'll have the opposite of 0, which is still 0. And then in the y spot, we're going to have x's. So we'll have the 1, the 4, the 5. And now we can go and actually plot these points. I should plot the points over here too. So I'm going to go ahead and hit pause and plot. Now I've plotted these points. So let me see here. When you did that quarter turn this way, notice it worked. So there's our rule. All right, let's come down here to the 180 degree rotation. So we want to know x comma y goes to what? So again, we're looking at what's in this place and what's in this place. So what is the new x and what's the new y? So when we do a half turn this time, because 180 degrees is a half turn, here we go. The new x is negative x. The new y is negative y. So we have negative x comma negative y. So notice that our triangle moved to over here. Let's actually find those points and see if they look like that. So we're just taking the x and we're making it the opposite. We're going to take the y and make it opposite. So we'll have negative 1, negative 2, negative 4, negative 3, negative 5, 0. Let's plot them. Connect your A prime, B prime, and C prime. And that looks exactly like it did when we rotated it on the patty paper. So it looks good there. Now rotating 270 degrees clockwise is going to be 3/4 of a turn clockwise. So let's come up with a rule. What's going to be here? What's going to be here? So if we rotate 3/4, so 1, 2, 3/4, we have negative y in place of x, and up here we'll have x. So negative y comma x. And the reason I'm showing it with you with patty paper is because if you ever can't remember, I'm showing you how you can actually figure out what these rules are. So let's go through and actually use the rule and come up with these points. We're taking negative of the y value for all of our x's. So y was 2, we'll make it opposite. Y was 3, make it opposite. Y was 0, make it opposite. Then our x's just become our y. So x was 1, x was 4, x was 5. We'll go ahead, we'll plot that. We'll connect them. And we'll double check that if we rotate 3/4, so there's 1, 2, 3/4 clockwise, we line it up, that looks like it worked great. So there's our rule for rotating 270 degrees clockwise. Now, let's rotate 3/4 of the way counterclockwise. So, what's going to be in this spot and what's going to be in this spot? What's the new x? What's the new y? So, counterclockwise. This is the way counterclockwise is. So 3/4 of that way. 1, 2, 3/4. We have y, comma, negative x. So then what we're going to do is let's use that rule. And if you pay attention though, you'll actually notice that this rule matches another rule that we already did. This rule was the exact same as this rule right here. So this is what our graph is going to look like. So I'm just going to copy that down here, and we're going to talk about it. So here's A prime, B prime, C prime, so let me zoom back out so you can see this all. These right here were the same. Okay, now if you look up here, notice these two were the same. So when we go to write our rules down here in this bottom corner, rotating 90 degrees clockwise, like in number 1, was the same thing as rotating 270 degrees counterclockwise. So the rules were the same. XY goes to Y, negative X. Rotating 180 degrees clockwise is the same thing as rotating 180 degrees counterclockwise. We didn't even do that one because a half turn is a half turn no matter which way you do it. XY goes to negative X, negative Y. 270 degrees clockwise, that was number 4. That was the same thing as number 2, which was rotating 90 degrees counterclockwise. And that rule had XY going to negative Y, comma X. So these 3 rules are going to be ones that you're going to want to make sure are on your cheat sheet because you're going to have to be using them. Let's take a look at your assignment. and if there's anything key we have to note in there. So 1 through 4, does it have rotational symmetry? 5 through 10, if one of these angles is 45, all of these angles are 45. Okay, so if it's rotating 45, it's rotating one of those. If it's rotating 90, it would be two of those. So you guys can kind of figure those out based on that. 11, 12, and 13, you're going to want to write out what the original point is. It says clockwise rotation. So 90 degrees clockwise, 180 degrees clockwise, 270 degrees clockwise. I would start out by writing your rule on this so that way once you have what A, B, and C are, you can use your rules to find A prime, B prime, C prime. So that's going to be using those rules, which is really important that you know how to do. You guys have had practice with this notation, so as long as you write that down, you should have no problem coming up with those new points. Draw the image of the figure after the given clockwise rotation. These ones, again, you're probably going to want to write out the points first. So actually name them, like A, B, C, D, and find where the new points go. Okay? So in order to get the points here, you're going to tell me that that's at 0, -2, which is going to go to, and you're going to find the new point. Because you're going to have to use your rule. So you probably want to write out the rule here, x, y goes to, what's that rule? So that way you can follow it. And again, these are clockwise rotations. Okay. 18 and 19 reflect JKL across the x-axis and then reflect across the y-axis. And you'll notice for part A it says to draw the final image. Okay, so you're going to do two transformations there, a reflection and a reflection. And you'll notice that your original to your image, so your pre-image to your image, can be described as a single rotation. So see if you can describe how that would have to rotate to go from triangle JKL to triangle J prime, K prime, L prime. And that is after both transformations. Okay. The error analysis, so see if you can try to find the error in that description. If you have any questions, let me know.